Today we are going to study about IoT architecture. So before studying what are the IoT architecture, we have to study some basic concept about IoT architecture. So actually, why do we need an IoT architecture? So what is the reason that we need an IoT architecture? The main answer is that we have to standardize things. We have to standardize things. So like say you're going to build a house, before building a house, the first you make is a sketch, right? A sketch plan of your house. Why do we do that? So that we know what are the things inside, so that we can plan in a better way. So similarly, before you build IoT objects, or before you build IoT things, you need something called as an IoT architecture. Why? Because there is actually a lot of companies there that they build these IoT objects, or IoT build and deploy these IoT devices. So when they build and deploy things, they want to make it standardized. So they need an IoT architecture. So if you have learned computer networks, we have in computer network, we studied about computer network architectures, right? So we have studied about some ISO, OSI models, and we've studied about some TCP IP models, and such things we have studied. And once when we studied those things, we studied about these architectures. Well, the problem is that we cannot really use this ISO, OSI model, or computer network, or IT architectures when we implement IoT. So this is not possible. Okay. So there are reasons behind it, okay, why we cannot use IT network architectures or IT architecture in IoT architecture. So that is the reason why we are trying to build a new IoT architecture. So what are the real reasons behind we are going to build a new architecture? So that one we call it as drivers. So that is the drivers behind new IoT architecture. Okay. So drivers means the reasons for building a new architecture. Okay. So the first reason is scale. So we know that the number of IoT devices is actually increasing day by day. So in the previous days we have computers, okay. So the computers were actually limited in number. These computers were limited in number. Say a person had one computer or two computers max. Okay, so the number of computers or number of computing devices were very less in number. But you say when we switch to IoT, every single thing that we see around is actually an IoT device. For example, when you look at your timepiece, for example, your watch, or your refrigerator, or your television, everything you see is an IoT device. Okay, so as a result, what we are doing is that the number of devices is actually skyrocketing. It's actually increasing at a fast rate. So what happened is that earlier we know in computers we used IPv4 or Internet Protocol version 4 for communication. But you see, IPv4 has got can support only lesser number of nodes or less number of devices. So after some time, or when we switched from IT to IoT, the number of devices actually skyrocketed. Now it is no longer possible for IPv4 to support all these machines, all these new devices that have come. So now, due to an increased scale, the number of devices that we use have actually increased. We can no longer rely on IPv4. So now we want the new version, or IPv6. And the IT networks, but you see there are some IT networks. For example, you see the computers, or your mobile phones, or some of these devices actually use a former version itself, IPv4. Now we have got two technologies here, right? Two protocols here, V4 and V6. Now you have to translate from IPv4 to IPv6, and this is called as network address translation, or NAT, network address translation. Okay, so that is the first reason for it, because of scale, the large number of deployment of IoT devices. And the second reason being security. You see, when we see this IoT devices, they are actually deployed using VSNs, or wireless sensor networks. Okay, these wireless sensor networks are actually physically exposed to the world. They are actually physically exposed to the world. So as a result, there is actually a large threat of security. There is a large security threat over there. So what we have to do is that we have to take note of it. Actually, we have to address those security issues that we face when we deploy IoT devices. Okay. So, the IoT devices for satisfying the security requirements should be able to do the following things. So it should be able to do a few things, like it should be able to identify and authenticate all entities. So let's suppose an IoT network. Okay, so let's suppose that this is an IoT network. We have got an IoT network here. Say a new node is coming and want to enter into this network. So we have to remember that we are using wireless sensor networks. We are not physically connecting the objects. Instead, we are using things like Bluetooth or Wi-Fi to connect these nodes. Okay. So when we do that, before connecting, we have to identify or authenticate these devices. This is very important. Then the second thing is that we have to ensure that all data is encrypted. So when we transfer data between the nodes, we have to ensure that the data is encrypted, or else what will be happening? This data can be stolen. Okay, we have to prevent that. So we have to ensure that the all data is encrypted. And then when we store data, we have to ensure that the storage is protected. We have to protect the storage, or else what will happen? Yes, new entities, or say some data vendors can access it unauthorizedly and can misuse your data. Okay, this is very important, so that you should be able to protect your stored data. And then you should be able to give network security, or else what will happen? If there is no security, intruders or hackers can come in between the networks and can hack your network connection. Okay, so that is the second reason for that. The first reason was scaling. The second reason was security. Unlike the other things that we have learned, or the IT devices that we have learned, these IoT devices are deployed using wireless sensor networks, and they are actually prone to greater threats of security. So as a result, we have to be concerned of the security challenges there. That is the second reason. And third one is that the constrained devices. See, you know that the IoT devices are actually deployed using large number of sensors. So sensors are actually the heart and soul of the IoT devices. So it is actually, we are actually deploying a large number of sensors. In future classes, you will learn about something called as star dust and all, where you are just deploying a large number of sensors all over the place. So there is actually large number of sensors, but there is a big problem that the sensors are actually constrained. Why? Because they have got limited power. They've got limited power. They have got limited processing speed. Then they have got limited memory. So as a result, these sensors are actually constrained. Then we are actually forced to work with these constrained devices. So what we have to do is that we should not give it too much of stress. Okay, we should allow data transfer when it is absolutely necessary. Only if the data transfer is absolutely necessary, then only we will allow data transfer. This is very important because we are actually working with constrained devices. We are not working with the computers where you have a large processing power and memory and everything. We are actually working with the small sensors or small devices. So the constrained devices are there. Then there is data. So data, you see, we are actually, though the nodes are constrained, we are actually sending large amount of data. Why? Because we are actually, as I told before, this we are actually deploying a large number, thousands of sensors. So each sensor is actually sending data almost throughout their life, or just like in every second or in every millisecond. So the data traffic is actually very high compared to the other things. Okay, and then again the data is unstructured. Not only is the data is of very large amount of data we are transferring, but we are also transferring unstructured data. So what we have to do is that we have to prevent unnecessary transmission of data, and we have to structure the data. Okay. The next reason being the legacy devices. What do you mean by legacy devices? You see, I have my mobile phone. Okay, after some point of time, the operating system or the service provider, they asked me to upgrade my mobile phone. Why? Because the operating system is now outdated. You have to upgrade it. Or the Wi-Fi is now outdated. You have to upgrade it. But you think about a factory. There is a large device. And you cannot really update it every often. Okay, so this is every now and then. We cannot really update it every time. So as a result, what we have to do is the upgradation is a difficult process. Upgradation is difficult in these legacy devices. That's why we are calling as legacy devices. Then again, there is another thing. You see, in IoT, not every device has got a unified protocol, or not using a unified protocol or anything. You see, there is actually modern IP supporting machines, IP supporting devices, and there is legacy non-IP devices. Non-IP devices. So there are actually some IP supporting devices that are very new, but also there are some legacy non-IP devices. So as a result, we have to take in charge of these legacy devices. We have to unify them in some way, and we have to incorporate these legacy devices as well. We cannot simply deny service there. So that is very important. And the next thing being the real-time data analysis. This is very important. Okay, why? Because these data that we collect, or that we kind of send and receive, and all this data, we are actually processing them in real time. We learn about things like fog computing and edge computing. We are actually immediately processing the data or immediately analyzing the data. This is not the same for any other IT devices. Okay, so as a result, we have to take in consideration all these things. That is, we have to implement scaling, there is security issues, and there is constrained devices, large number of data, we have legacy devices, and we need real-time data analysis. And all these are the reasons why we need an IoT architecture, why we cannot use the former IT architecture for IoT devices, and we want to build a new IoT architecture. Now, when we talk about IoT architecture, there are actually many standardized architectures. But here we are actually studying about three IoT architectures. The first one is the 1M2M. 1M2M standard architecture, and the second thing is IoT World Forum architecture, and then we are studying a simplified IoT architecture. So